All right. Hey, everybody. This is the walkthrough video, real quick, for solve and graph inequalities that we did in class today, Friday, August 26th. I'm going to try to go through this pretty quickly. Yeah, well, here we go. All right. What an inequality is, it's a mathematical sentence that compares quantities. Okay, so it's a comparison of two different quantities. All right. These are the inequality symbols. So I'm going to write what they are, and I'm going to explain a little bit about them. So this is less than, this is greater than, this is less than or equal to, this is greater than or equal to. Okay, this is kind of a refresher, maybe from 7th grade, maybe from 6th grade. But in here, we are going to, next week, we are going to start translating words, word problems, things like that involving inequalities. Okay, so there are a couple things that I want you to write underneath here if you're following along here. So in word problems, you may see some of these sorts of phrases that I'm about to write here. So less than, what you might see is in the words, you might see something is less than. Okay, might be something along the lines of is smaller than. Maybe something is fewer than. Okay, is less than, is smaller than, is fewer than. What you might see in for greater than is basically going to be the opposite of what less than is. So if it's is less than, you might see is greater than. Is smaller than, maybe is larger than. Is fewer than over here is more than over here. Okay, for less than or equal to, you might see something that says something is less than or equal to. I'm going to abbreviate this because I don't have enough room. So this stands for less than or equal to. Then what you might see a bit more commonly in word problems is going to say is no more than. Okay, is no more than. So something that is less than or equal to is no more than some other quantity. And then finally, you might see is at most, meaning it can only be as much as what these quantities are. Okay, greater than or equal to is going to be kind of the opposite of these guys here. So is less than or equal to, this would say is greater than or equal to. No more than, this would be is is no less than. And is at most over here would be is at least. Okay, so these are kind of the words and phrases that you would see used in word problems for inequalities. All right, so to solve our one-step inequalities, we're going to solve these a lot like the equations. So I'm going to start by saying use inverse operations. Okay, use inverse operations. So these first few problems here, which by the way, I'm going to go down the line here, and then the ones on the right, that is what you are going to do when I give you time, or you don't have to. It doesn't matter to me. I'm going to do them either way. Okay, so for the first one, we've got -6 is greater than or equal to n minus 5. By the way, we read inequalities just like we do words, left to right. Okay, that's why this is the greater than, I think I said greater than or equal to sign. So -6 is greater than or equal to n minus 5. So I'm going to draw a line there, split it. I need to get my constant, which would be this negative 5, to the other side. So I'm going to add 5 to both sides. Negative 6 plus 5 is negative 1, greater than or equal to n. So this is my solution right here. Now we are going to not only solve, but also graph these inequalities. So here's how we do it. On this line right here, I'm going to make it into a number line with the arrows. What I like to do is I like to take my solution number, put it dead center right there, okay? So there are a lot of numbers that could be in. So negative 1 is greater than or equal to a lot of numbers. In order to determine what those numbers are, what I like to do is put a couple numbers bigger, a couple numbers smaller. Okay, so bigger than negative 1, you pick. I'm going to use maybe, I know 5 is bigger than negative 1. No, 10 is bigger than negative 1. Smaller than negative 1, negative 5, negative 10. Okay. So if we're looking for a solution to make this inequality true, negative 1 is greater than or equal to n. We first need to determine, well, can n actually be negative 1? That answer is yes, because it says greater than or equal to. So if that's the case, we are going to use a closed dot. So we're going to use a closed dot at the solution when graphing either less than or equal to or greater than or equal to. All right. So we're going to use a closed dot. Make sure you make it noticeable for me. All right. There we go. It can be negative 1. It also can be greater than negative 1. What I'd like for you to do, at least on this one, is substitute these numbers in, one of them, into n. What I'm going to use is this. So I'm going to go negative 1 is greater than or equal to negative 10. And I'm going to go negative 1 is greater than or equal to positive 10. You're going to shade in the direction of whichever inequality makes n true, or makes this inequality true. So is negative 1 greater than or equal to negative 10? Negative 1 greater than or equal to positive 10? The answer is this one. Negative 1 is greater than or equal to negative 10. So what you'll do, and I'm going to have to kind of turn this, you're going to shade along that number line in the direction of the arrow that you want to go, because everything that would be to the left of negative 1 would make this inequality true. Okay, so that's the first one. Going underneath. 2 is greater than a plus 1/2. I'm going to set this up the same way. All right. I'm going to subtract 1/2 this time. 2 minus 1/2 gets me 1 and 1/2. You can put 1.5 if you want. You could put 3/2. It doesn't matter to me. I'm going to go ahead and make that inequality sign down there. These guys are gone. So 1.5. 1.5 is greater than a. Now I do the exact same thing that I did up here. I'll start with my 1 and 1/2 solution. Oops. Make the arrows, don't forget. Pick two numbers that are larger, two numbers that are smaller. 1.5. I know 5 is larger. I know 10 is larger. I know negative 5 is smaller. I know negative 10 is smaller. Okay. We first have to determine, can our a variable, can it actually be 1.5? Well, 1.5 greater than 1.5. Is that true? No, of course not. 1.5 equals 1.5, but it is not greater than itself. So when that is the case, you're going to use an open dot when graphing either less than or greater than. Notice how it's not the or equal to like we had up here. So an open dot is just going to be a circle around where the solution is. Okay. Then substitute in some numbers. I'm going to do this mentally. You can write them down if you want, but I'm going to use a negative 10 and a positive 10 to substitute in here. So I'm going to ask, is 1 and 1/2, is it greater than negative 10? Or is 1 and 1/2 greater than positive 10? 1 and 1/2 is going to be greater than negative 10. So whichever direction makes this inequality true, that's what you're going to shade in. So I'm going to shade towards what makes this true, which is in the direction of negative 10. going to shade right along that line. Okay, there we go. Moving on to the next one. 40 is greater than or equal to 8x. Okay, this 8x is multiplication, so we will undo that multiplication with division. Divide both sides by 8. 40 divided by 8 is 5, is greater than or equal to x. All right, so that is my solution right there. All right. Again, we need to graph this. Put the arrows on the ends. My solution is at 5. Can x be 5? It says greater than or equal to. Yeah, 5 is equal to itself, so this will be a closed dot. Pick a couple numbers bigger, a couple numbers smaller. 5, let's go 10, 15, 0, -5. Which numbers make this x, make this inequality true? So is 5 greater than or equal to 0? Is 5 greater than or equal to 10? 5 is greater than 0, so I'm going to go in the direction that makes the inequality true, that way. We got one more that I'm going to walk you through, and then I'll have you pause this and then try these. If you don't pause it, obviously, then it's just going to be awkward, but that's okay. This last one's kind of important. Okay, so we'll start the same way. Now we have x over -3, which is a division problem. In order for us to undo division, we're going to multiply. So I'm going to multiply both sides by the denominator of this fraction, which is -3. Here's the thing that's different with inequalities and equations, okay? And this is something to remember over here. When you multiply or divide an inequality by a negative number, there's a reason this is capitalized. There's a reason why I circled it. I'll show you in the upcoming problems here. When you multiply or divide by a negative, the inequality symbol must be reversed. Has to be, okay? Here's what this is going to look like. These -3's cancel. X comes down. 4 times -3, that's a -12. That's 2. That's a -12, okay? Since we multiplied by a negative on both sides, this inequality sign has to reverse. So instead of it reading less than or equal to, it will read greater than or equal to, okay? Sign reversed because we multiplied by a negative number. All right? So once you have your solution, which this is the solution, you can go ahead and graph this as you normally would. The graphing does not change because of this whole rule here. All right? So I'm going to go -12 here. Greater than or equal to -12. It can be -12. So that is a solid dot, closed dot. All right? Pick a couple numbers bigger, a couple numbers smaller. -12. 0 is bigger than -12. 10 is bigger than -12. -20 is smaller than -12. -30 smaller than -20. Okay. Which of these numbers makes this inequality true? So x is greater than. So what number is greater than or equal to -12? 10. 0. Anything this way. So 10 is greater than -12. Any positive number or 0 is greater than -12. So I'm going to shade in that direction. Okay, I'm going to shade in that direction. Okay. All right. What I'm going to do, because this thing has a feature where I can pause this, I'm going to pause this video. Can I do the thing? Okay. I'm going to pause this video real quick here, And then hopefully when you unpause it, or if you don't unpause it, I don't know, all of these will fill in. If you don't pause it, I guess it'll look like magic. So here we go. Okay, we're back. I guess if you pause the video, we're back. This is what I got. The last one was everything else. These first three were pretty straightforward. This bottom one, though, had this rule, this multiply or divide by a negative number. So I had to reverse the sign. You can see we went from greater than to less than, but it didn't change the graphing. Again, all I did on all of these to determine which direction I was going to shade in, I plugged the numbers in. That's why we put the numbers here. Okay, we put the numbers so we can use those as variables. Okay, so that's the first one. Backside. Okay, backside. Here we go. So this is two steps. So it's going to be done essentially the same way. Essentially the same way. So I'm going to do a few of these. There's a couple in particular that I'd like to point out. So I'm going to fill out my steps and everything over here first. So just like a two-step equation, you're going to move your constants to one side or to the other side. And then just like the one step on the other side, you're going to use inverse operations. Okay. Graphing inequalities. This is still the same rules. I'm just going to have it here as a reference for me. Use a closed dot at the solution when graphing less than or equal to or greater than or equal to. Use an open dot when it's just less than or just greater than. Okay, and again, something to remember that you're going to see in some of these. Whenever you multiply, and it's just multiply or divide. It's not add or subtract. It's just multiply or divide by a negative. The inequality symbol must be reversed. Okay? So there's my hints right there. Not hints, my steps, my rules, whatever you want to call them. There they are. Okay? So this first one here, 3x plus 4, is greater than or equal to 16. Okay, so I'm going to split this up here. First step, move constants to the other side. This 4 is a constant, so I'm going to subtract 4 on both sides. This will cancel. We got 3x is greater than or equal to 12. This is multiplication. Undo it with division. Divided by 3, divided by 3. X is greater than or equal to 4. That's my solution. All right. Make your arrows. Bring your solution down here at 4. It can include 4, right? X is greater than or equal to 4. 4 is equal to itself, so we'll use a closed dot. Pick two numbers bigger, two numbers smaller. 4, let's go 10, 15. Let's go 0, -5. Those will work. You pick what you want. I just kind of like increments of 5. It's nice and neat and easy to substitute in. So does a 10 or a 0 make this inequality true? Is 0 greater than or equal to 4? Is 10 greater than or equal to 4? 10 is greater than or equal to 4. So I'm going to shade in that direction. All right, there we go. Two-step inequality. All right. I'm going to go underneath here. All right. 5 minus 4x less than 33. Split it up. I need to get my constants to one side. This 5 is a constant and it's positive. So I'm going to subtract 5 from both sides. Which, remember, this is a negative 4x, so make sure you bring down that negative included. Negative 4x is less than 28. That's what that is. This is multiplication. Undo it with division. And I have to divide both sides. Have to divide both sides by a negative. Okay, so just like my rule down here says, when you multiply or divide by a negative, meaning on both sides, you have to reverse the sign. So x comes down. 28 divided by -4 is -7. And then this less than sign reverses to become greater than. Just like that. Okay. Graphing this is still the same. Make your arrows. Bring your solution down. -7. X is greater than -7. -7 greater than -7? It is not. So this is going to be an open dot. Two numbers larger, two numbers smaller. -7 to 0, 0 to 10. That works for me. -7 to -10 to -20. That works for me. Okay, this is true. This number line is true. Which number makes this inequality true? Is 10 greater than -7? Is -10 greater than -7? Well, any positive number is greater than any negative number. So I'm going to shade in the direction of the positives here. Okay, positives there. That's it. That's it. That one's done. I'm going to do this one last one here, and then I will let you guys try the ones on the right. Okay? Here we go. Split it. Move your constants to one side. I'm going to do that by subtracting 9 on both sides. These will cancel. You have an x over 2 is greater than or equal to 5 minus 9 is -4. Okay? Now, this problem is interesting. Because we have to think about this rule down here, sort of. All right, so let me explain. Since we have x over 2, that is a division problem. The inverse of division is multiplication. So we are going to multiply by the denominator. That denominator is a 2. This 2 on both sides is positive. Our rule says when you multiply or divide by a negative, meaning the one that is going to be on both sides, that's when you reverse the sign. However, this 2 is positive. So even though we have a negative term here, which is why the confusion might happen, even though this is negative, since the number on both sides is positive, we do not reverse the sign. So I'll cancel this. X comes down. -4 times 2 is -8. But our sign, or symbol, inequality symbol, stays the same. It does not flip to less than or equal to. So that is my solution. That's why I like this problem right here, because a lot of students normally get confused with this rule. But it's only when, like up here, we were dividing by -4 on both sides. The negative was on both sides. So that's why we reverse the symbol. Here, don't have to do it because the number that we're multiplying by is positive on both sides. Okay, go ahead. Let's graph this. -8 is the solution. It's or equal to, so this will be included in there. Pick two numbers greater, two numbers smaller. Let's see, -8, 0 is bigger, 10 is bigger. -10 is smaller, -20 is smaller. That scale is awful. That's okay. What makes it true? Is 10 greater than or equal to -8? Is -10 greater than or equal to -8? In this case, any positive number is larger than any negative number. So I'm going to go this way. There we go. All right, just like that. Now we've got these three here. I can't zoom out on my camera anymore because it does not work like that. So I'm going to pause the video, solve them, kind of walk through them a little bit, and then that'll be it. Okay. Here we go. Ta-da! Just like that. Answers. Hopefully pause the video. If not, this is awkward. But yeah, so this one, what we ended up having was a -2x here, so we had to divide both sides by a negative, which means we reversed our signs. So hopefully you remembered to do that. It was a greater than sign, so we got an open dot, and then shading to the left made this inequality true. Okay, so -2 is greater than -10, -5, anything in that direction. And the second one here, the second one we have -6 is greater than x. Okay, so I add the 5. This was a similar problem like the one down here, I think, where you would think you would have to switch the sign or reverse the sign, but because you're not doing negatives on both sides, you don't have to switch the signs. So you keep it as a greater than sign. It's an open dot because it is greater than, and then -10, -15, all those numbers would make this inequality sign true. So that's what we got. Bottom one down here, subtract 8 from both sides, you get a -1 on the left. And then because this is a negative x over 3, you'll multiply both sides by that -3. So since you multiply both sides by a negative, our sign goes from greater than or equal to less than or equal to. Okay, and that pretty much takes care of that. All right, make sure you get your homework done. Other than that, have a great weekend or whatever day, night you are watching this.